This video begins with a basic introduction. SQL stands for Standard Query Language and it is also known as SQL or sometimes SQL. The major purpose of this database language is to keep the data rational database management system. It is a unique tool used by data experts to manage structured data. It also intended for RDMS streams processing also. It is provided by American National Standard Organization, adopted by all the database vendors like MySQL, Microsoft, etc. It is the most crucial query language to understand if you want to work in database. SQL is used by large companies like Facebook, Instagram, and LinkedIn to store data from back to end.
As you might know, the what SQL stands for Structured Query Language. So inside SQL, there are certain commands that we give to the SQL to perform some task. So SQL commands are instructions that are used to communicate with the database and to perform tasks, functions, and queries with the data. SQL commands can be used to search database and to do further functions like creating tables, adding tables, modifying tables, and deleting tables. So SQL commands are basically the commands that you give to the SQL and they perform a certain type of function for creating tables, modifying tables, or modifying data, or to insert data or to delete some data. You can use the SQL commands. So we are going to talk about DCL commands. So there are three types of DCL commands. One is DDL, which is data definition language. One is DML, which is data manipulation language, and the third one is DCL. So data definition language is a set of SQL commands used to create, modify, and delete the database. So basically what DCL is all about is that if you want to edit the database, not the data inside it, so you can use the DCL function. So DCL functions are, these are the commands are normally not used by the general users. So these commands cannot be used by the general users. You have to download a special app for it and the database can be accessed via that application. So DDL commands usually is used to create or modify or delete the database. The second type of SQL command that we are going to talk about today is DML, which stands for data manipulation language. So the examples of data manipulation languages are insert, delete, modify, and select. So the DML commands are used to edit the data that is already present in the database. So if you want to add something, so you can use the insert command. If you want to delete a data, you can use the delete function. If you want to select a particular amount of data, so you can use the select function. So these are the functions, these are the DML commands that are used to edit the data that is already present in the database. The third type of SQL command that we are going to talk about is DCL. DCL includes commands like grants and revoke, which mainly deal with the rights, permissions, and other controls of the database system. So, the grant function of the DCL is used to give users access privileges to the database. So using the grant function, the user can get the privilege to access the database. Whereas the revoke command is used to withdraw the user's access privileges which was given by the grant function.
The database query language SQL is used to carry out the operations that we have expressed before. Now we will see how we can express these queries using SQL. First, we have to create a database and then we have to retrieve this database. Now we will create a table with the column names and the column type that we want, which is integer or varchar or char. Now we have to insert values into this table. What we have to notion here is that anything other than integer should be in a string. You can click the up arrow button to retrieve the previous query and just change the values that you have to change. Even though SQL is case insensitive, we should write the column headings or the attribute headings correctly. After inserting the values, we can retrieve the table using the select star command. The SQL statement select departure underscore time from flights where destination equal to Detroit is used to find the projection P5 on the department time attribute of the selection of 5 tuples in the flights database that satisfy the condition destination equal to Detroit. So SQL will retrieve the data where the output where it matches the condition that the destination equal to Detroit. The output would be a list containing the times of flights that have Detroit as their destination. SQL uses the from clause to identify the NRA relation in the query is applied to the word clause to specify the condition of the selection operation and the select clause to specify the projection operation that is to be applied. SQL uses select to represent the projection rather than a selection operation. We can now have another example using two tables. As we have discussed before, we have to again create a database or use the same database, and we have to create a table, insert values into the table, create another table, insert values into that table too. Now we have the SQL statement, select professor time from teaching assignments class schedule where teaching underscore assignments dot department equal to mathematics. Beware to mention which table you are using so that the department would not be ambiguous. Which this is used to find the projection on the database, which joins the teaching assignments table and the classing schedule table. Now they look for the condition which satisfies department equal to mathematics. The output would consist the single two tuple which satisfies the condition, that is department equal to mathematics. The SQL from clause is used here to find the join of two different databases. A relation is used here to retrieve the output and
R on set A is said to be reflexive if A comma A belongs to R and A belongs to every set A. A real life example for reflective relation can be a person is always equal to himself.
Just like that, a relation said to be reflexive if in a number 1, comma 1, 1 will obviously belong to itself.
Relation R on set A is said to be symmetric if A comma B belongs to R and B comma A belongs to R. If Angelo is a friend of Rohan, then obviously Rohan is a friend of Angelo.
Relation R is said to be symmetric if 1, comma 2 belongs to R and 2, comma 1 also belongs to R.
A relation R on set A is said to be antisymmetric if and only A comma B belongs to R and B comma A belongs to R, then A is equals to B.
Relation is said to be asymmetric if A, comma B belongs to R, then B, comma A does not belong to R.
Relation R on set A is said to be transitive if A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R. A real life example for transitive relation is if Rohan is a friend of Angelo and Angelo is a friend of Danish, then Rohan and Danish are both friends.
A relation R is said to be transitive if 1, comma 2 belongs to a set A and 2, comma 3 belongs to a set A, then 1, comma 3 will also belong to the set A.
So as we have learned in the previous by the previous students about SQL. So SQL is basically structured query language. Now how do you analyze it with data is what we're going to learn now. So to understand SQL, one of the most important things is to know the types of functions in this database. This can be compromise of two things, or like two, you can say, methods. One is you first analyze the data to simplify the data, because huge amounts of data cannot be just taken and started to work on it. You need to analyze it, you need to simplify it, and then you need to design a database model so as to work on it. Other thing is, while you understand these relations, it is known as one of the essential steps in this database theory, where you have to understand the data. So coming to the types of relations, or like the functions in the relations, we have three: one-to-one, one-to-many, and many-to-many. Now we will focus on one-to-one. So what is one-to-one? It is basically, in this type of relation, one record in one table corresponds to just one record in the other table. Now, as we know, we are in a college, thousands of students, each individual person. How do they collect so many data? That's when our IDs come in hand. So each student has a particular or unique ID, and you can say that in terms of products and their barcodes, there will be one particular barcode for one product. And because of this, understanding and storing this data makes it easier for the big companies or even colleges and schools. Now we'll come to the second type of function, that is one-to-many relation. So as the name suggests, let's take, for example, there are two tables. So a record from one table can be related to one or more records from the second table. But there's a catch in this. That is, from one record from the second table cannot be related to one or more records from the first table. Let's take, for example, in a bank, a person can hold up to 1 to 10 accounts, but the account can be owned by only one single person. Another example we can go to is the Google Classroom that we all have been using. So a professor posts an assignment and he sends it to many students. But once the students complete their assignments and when they post it, it goes directly to the professor. So in this way, one-to-many functions can be related. Now we will come to the last type of relation, that is many-to-many. So let's take, for instance, many records from one table are related to many records from another table. For example, let's take we students. We can opt for different subjects. We can opt for many subjects, and a particular subject can be opted by many students. Another example you can say is, when you go on Amazon, you purchase a product.
This product can be purchased by many others, and you can also purchase many products. So that's how you can simplify many to many relation.